Bismillahirrahmanirrahim. In this video, we are going to be starting a new book, Islamic Science and the Making of the European Renaissance by George Saliba. This book is very important to understand the classical narrative, as this book debunks the classical narrative or classical narratives, and then the author presents his own narrative by using the field of astronomy as a template. But before we go into this book, let us see what is meant by Islamic science. So the explanation is given by the author himself in the book, which is here. Islamic science is intended to designate those sciences that were developed in the Islamic civilization and which did not fall within the sphere of disciplines usually designated with the Arabic expression al-ulum al-islamiyya, which are Islamic sciences. So it's not Islamic sciences, it's Islamic science. The later group, al-ulum al-islamiyya, usually dealt with religious Islamic thought proper and thus is not of centered concern in this volume. In contrast, the Islamic sciences studied here were considered as part of the foreign or rational sciences, ulum al-awail or al-ulum al-aqliyya, or even the philosophical sciences, al-ulum al-falsafiyya or al-hikmiyya in classical Islamic times. Islamic is therefore used in this more complex civilizational sense and not in the religious sense. So now we know what is mean by Islamic science in the title of the book. So let's start with the chapters. So this book has 7 chapters and the first 2 chapters are interlinked, as the first chapter presents the questions which the classical narrative cannot answer, and also it presents the problems with the classical narrative and the different variations of the classical narrative. And then the second chapter gives us an alternative narrative. So let's start with the first chapter, the Islamic scientific tradition, question of beginnings 1. First off, the classical narrative. The classical narrative has some basic assumptions. Islamic civilization originating in the desert lacked scientific development and relied on contact with advanced neighboring civilizations, Greco-Hellenistic, Sasanian, Indian for inspiration. A translation movement during early Abbasid times, 750 to 900 CE, brought these ancient sciences into the Islamic fold. This process spurred a golden age of Islamic science seen as a reenactment of Greek intellectual glory. Depiction of contributions. Islamic science is rarely credited with originality or transformative innovation. Contributions are often framed as incremental additions to Greek science. The decline of Islamic science. The narrative attributes the decline of Islamic scientific tradition to conflicts with religious orthodoxy. Figures like Abu Hamid al-Ghazali are often cited erroneously in some cases as catalysts for this decline, particularly through works like Tahafatul Falasifa, which is often misquoted as Tahafatul Falsifa. Role in the European Renaissance. Islamic science is portrayed as a brief intermediary between the classical Greco-Roman world and the European Renaissance. During the 12th century Renaissance of translation, major Arabic texts, many of which had earlier Greek or Indian origins, were translated into Latin. After this period, the narrative suggests Europe moved on from Islamic contributions and sought a direct connection with Greco-Roman sources, sidelining Islamic science. Critique of classical narrative. The narrative oversimplifies and misrepresents Islamic scientific achievements. Islamic scholars are depicted as mere transmitters rather than innovators. It dismisses the possibility of a distinct Islamic scientific worldview or the critique of inherited Greek science. The role of religious orthodoxy in the decline is often exaggerated or misunderstood. The continuity and influence of Islamic science in later European developments are downplayed. Central theme. The importance of Islamic science is undeniable, but its portrayal in classical narrative is reductive. Revisiting and correcting misconceptions about Islamic civilization's role in global scientific development is necessary to appreciate its true contributions. Critique of the classical narrative. Oversimplification of Islamic civilization's origins. The classical narrative tends to portray Islamic civilization as isolated in a desert environment. The author argues that this is an oversimplification. Nothing that Islam arose in urban centers like Makkah and Medina, surrounded by regions with established scientific traditions in astronomy, medicine, and other fields. This challenges the notion that Islamic science emerged in a cultural vacuum. Different transmission theories. The classical narrative creates the impression that the birth of Islamic science took place during the early period of the Abbasid times as a result of one or more of the following processes of transformation. Number 1. Contact theory. The contact theory posits that the expansion of Islam in territories like Byzantium and Sasanian Iran facilitated the transfer of scientific knowledge. However, the author points out that by the time of early Abbasid period, the surrounding civilizations were no longer producing scientific texts of the caliber of classical Greek works. The translation from Greek into Arabic during the Abbasid period often involved searching for lost texts in former Byzantine territories, suggesting that the knowledge was not actively circulated or preserved in those regions. This raises the question of how such advanced texts were accessible if no active scholarship was ongoing in those areas. Number 2. Pocket transmission theory. Another theory proposes that ancient scientific texts were preserved in a few cities like Antioch, Haran, and Jundishapur, and that these cities served as repositories for Greek knowledge. However, the author argues that this theory is implausible. Preserving those texts does not guarantee that people would understand it. Moreover, scientific and philosophical ideas usually flourish through open discussions. Instead, there were some major reversals in the scientific knowledge. For example, Cosmas in Lycopleistus proposed a flat Earth about 800 years after Eratosthenes measured Earth's circumference. Furthermore, the lack of evidence for a thriving scientific tradition in these regions makes it unlikely that such isolated pockets of knowledge could have influenced the development of Islamic science. science. Number 3. Syriac transmission theory. Some suggest that Greek texts were transmitted to the Islamic world through a Syriac intermediary. While there is evidence that Syriac scholars like Paul the Persian and Sergius of Rassina engaged with Greek scientific traditions, the author argues that these works were elementary and did not match the sophistication of classical Greek science. Thus, the Syriac transmission theory cannot fully explain the rapid advancement of Islamic science during the Abbasid period. Timing of the transmission. There still remains a second and more important problem, that of the timing of this transmission, which the classical narrative locates around the beginning of the Abbasid time. Why at that time in particular and not during the earlier 100-year rule of the Umayyads? What was so special about the Abbasids? Here, the classical narrative offers three plausible explanations for that starting point, two of them corollaries of one another. The first one is Persian legacy argument. Proponents of the classical narrative often suggest that the Abbasid Persian supporters sought to reclaim a lost Greek scientific heritage thought to have been appropriated during Alexander the Great's conquest. The author dismisses this claim as largely speculative, pointing to the lack of robust evidence for such efforts during the Sasanian period. Instead, he highlights a distinction between the earlier, more rudimentary translations of scientific texts into Syriac or Pahlavi and the later Abbasid focus on the advanced theoretical works like Ptolemy's Almagest and Euclid's Elements. Number 2. Dream of Al-Ma'mun. This theory asserts that ascension of Al-Ma'mun to power in 813 CE and his reliance on the Mu'tazilite school of Kalam as a state theology. This particular caliph is often endowed with an interest in the philosophical sciences and a preoccupation with introducing the Mu'tazili doctrine in the realm, so much so that he began to see dreams that justified his disposition. In one of those dreams, he is supposed to have seen Aristotle himself and to have had the chance to interrogate the great master about the great ethical and philosophical issues of the day. And third one is also similar to the second one, Mu'tazila and the Mihna. The third motivation is also associated with the Mu'tazilis and their connection with the Al-Ma'mun, who made their doctrine official state doctrine. This policy was also followed by two of his successors and eventually led to a type of inquisition often referred to in the sources as the Mihna. This climate is supposed to have energized philosophical thinking, and thus it must have motivated the acquisition of the major Greek philosophical texts and thus opened the doors for the vast translation that followed. However, Saliba notes that this connection is tenuous, as the most significant translation activities occurred after the decline of Mu'tazili influence during Al-Mutawakkil's reign, who actively opposed Mu'tazili doctrines. Bureaucratic patronage. Saliba emphasizes the critical role of Abbasid bureaucrats such as the Banu Musa brothers in commissioning translations and fostering scientific inquiry, often independently of direct caliphal intervention. This bureaucratic engagement shifts the focus from individual rulers to a broader systemic framework that supported intellectual activity. Other problems with the classical narrative. Astronomy and advanced knowledge before Abbasids. In 762 CE, the horoscope for Baghdad's foundation, preserved in historical texts, demonstrate advanced astronomical knowledge. It involved Ibrahim al-Fazari, an Arab astronomer, collaborators like Naubakh and Mashallah al-Farisi. Fazari and his collaborator Yaqub bin Tariq also translated complex Sanskrit texts like Al-Sindh under Caliph al-Mansur long before the supposed start of Abbasid translation projects. Fazari authored theoretical works Tarkib al-Aflaq and adjusted Persian astronomical texts to Arabic calendars, indicating pre-Abbasid expertise. Mature translations with advanced technical terminology. Al-Hajjaj bin Mattar's Arabic translation of Ptolemy's Almagest showed mastery of technical Arabic terminology, corrected errors in the Greek original. This maturity could not have emerged in a single generation, challenging claims that translation began under Al-Ma'mun. Pre-Abbasid scientific activity. Key texts like Elements, Almagest were likely translated under Khalid al-Barmaki, Harun al-Rashid's Wazir, or even earlier under Al-Mansur. Such sophistication required a long tradition of intellectual and linguistic preparation. Development of algebra and mathematics. Muhammad bin Musa al-Khwarizmi created algebra, Al-Jabr, independently of Greek sources, suggesting prior mathematical advancements. Innovations like decimal fractions and projection methods emerged soon after, reflecting a sustained pre-Abbasid foundation. Creation of Haya and other new disciplines. Gustav bin Luca and others developed discipline like Ilm al-Haya, astronomy, not present in Greek sciences. Translators also authored original works, blending translation with creativity. Innovations beyond translation. Habash al-Hasib advanced trigonometry and astrolabe design, surpassing Greek and Indian achievements. The Indian numeral system was refined, with decimal fractions emerging by the 10th century. Conclusions and challenges to the classical narrative. Scientific achievements attributed solely to Abbasid caliphs were likely built on earlier foundations. Translation and innovation were not isolated phenomena, they were part of a longer, more integrated intellectual tradition. The classical narrative must address who trained the earlier translators and astronomers, how advanced technical terminology and methodologies predated Abbasid patronage, scientific instruments and observational astronomy, innovations in instruments. Habash al-Hasib developed new astrolabe projections tailored to Islamic practices such as determining the direction of Makkah, Qibla, and distances for pilgrimage. These innovations required advanced geometric and trigonometric knowledge, gradual progression, not abrupt invention as suggested by the classical narrative. Refinement of observational data. Islamic scientists critically re-evaluated data from Greek and Indian sources. Ptolemy's value for the ecliptic inclination and Indian sources were corrected to approximately 23 and 30 degrees during the 9th century. This value view remains accurate today, underscoring the precision of their methods. These corrections could not have come from novice astronomers but from experienced observers with a deep understanding of their craft. Improved astronomical parameters. Early Islamic astronomers redefined key astronomical measurements, including the precession of the equinoxes, determined as 1 degree per 66 years, the solar equation and motion of the solar apogee, which Ptolemy assumed to be fixed. Achieving such results required a developed tradition of observational techniques, sophisticated instruments, and mathematical vigor, prolonged engagement with astronomical theories and practices. Critique of Greek astronomy. Muhammad bin Musa bin Shakir and his brothers Ahmad and Hassan criticized Ptolemy for the incoherence of celestial sphere mechanics and deemed certain motions physically impossible. Challenged Ptolemy's method for determining the solar apogee position. These critiques reflect a high level of theoretical and observational sophistication, far beyond the capacity of those supposedly just beginning to study Greek texts. Problems with the end. Persistence of scientific activity post-Ghazali. Contrary to the classical narrative, scientific production in the Islamic world flourished after Ghazali's critique of philosophy. Fields like mechanics, astronomy, optics, pharmacology, and medicine saw groundbreaking contributions from figures such as Jazari, Tusi, Ibn al-Nafis, and others. Distorted evaluation of contributions. Later Islamic scientific works were often dismissed or deemed insignificant by Orientalists and proponents of the classical narrative. The Renaissance is typically portrayed as an independent European enterprise, ignoring Islamic contributions and their influence on Renaissance thought. Neglected cross-cultural exchanges. The exchange of knowledge between Islamic and Byzantine civilizations, such as Arabic to Greek translations, remains largely unexplored due to the narrative's emphasis on rediscovering classical Greek antiquity. Figures like Hostel, who engaged deeply with the Arabic text, demonstrate the overlooked integration of Islamic science in Renaissance Europe, about which we will talk about in the later chapters. Astronomy as a case. Advanced achievements in Islamic astronomy post-Ghazali were ignored, even though they significantly influenced Copernican theory. Misinterpretation of the work, like those of Tusi and Bar-Hebrius, reflect the limitations imposed by preconceived notions of Islamic intellectual stagnation, medicine, and the legacy of Ibn al-Nafis. Ibn al-Nafis' revolutionary understanding of pulmonary circulation was marginalized, delaying recognition of its connection to later European discoveries. His critical approach followed a tradition of questioning Greek authorities, a hallmark of Islamic scientific methodology. Impact of the classical narrative. By dismissing later Islamic achievements, the narrative deprives both Islamic and the European intellectual history of a nuanced understanding of their interconnectedness. This exclusion perpetuates misconception about the origins and development of Renaissance science. This whole critique challenges us to rethink the history of science as a continuous and interconnected process rather than a segmented narratives of Eurocentric worldview. And that is the end of this chapter. And in the next chapter, we are going to be looking at an alternative narrative which would answer all these questions and make us look at the Islamic science from very different perspective. Stay tuned for that one.